The objective today is we're going to define a mole and Avogadro's number, and then we're going to calculate the molar mass of a substance. The different types of moles, the animal, the mole on the skin, but we're going to talk about a scientific mole, which is a number, 6.02 times 10 to the 23rd. 1 mole is the amount of a substance. Just like 1 dozen is 12 of an object, like a dozen eggs, 12 eggs, a dozen roses, 12 roses. 1 ream equals 500 objects. 1 pear is 2 objects. 1 mole is equal to 6.02 times 10 to the 23rd object. A pair, dozen, or even a ream of molecules would be too small to see. Chemists had to create a bigger unit for counting atoms and molecules. The unit we use is called a mole. 1 mole of anything has 6.02 times 10 to the 23rd items. This number is called Avogadro's number and is usually written in scientific notation as 6.02 times 10 to the 23rd. Scientists are lazy, so we abbreviate mole to mole without the E. Big difference, right? Avogadro's number will be 6.02 times 10 to the 23rd, which is 1 mole of objects. 1 mole of anything has 6.02 times 10 to the 23rd items. So how big is a mole? How big is Avogadro's number? We're going to watch this YouTube video after we complete my note video and see. So here's a picture of Amedeo Avogadro. A mole can be measured in mass, volume, or number of representative particles. So a single element is going to be called an atom. Molecular compounds is going to be molecules, and ionic compounds are formula units. And Avogadro is the person who came up with this number. So let's talk about molar mass for a second. The grams of 1 mole of a pure substance is equal to the molar mass. 1 mole of any element or compound or formula unit equals the average atomic mass from the periodic table measured in grams. Here we have mercury on the periodic table, and by the way, regardless of your periodic table, we're just going to always deal with 2 decimal places. So mercury is 200.59 average atomic mass, which means 1 single atom would have 200.59 atomic mass units, or 1 mole of mercury would have 200.59 grams per mole. To find the mass of 1 mole of a compound, you find the total atomic mass for each element and you add them together. So if I wanted to calculate the molar mass of lithium nitrate, I would take 1 lithium plus 1 nitrogen plus oxygen times 3, and that would give me the molar mass of lithium nitrate. If I wanted the molar mass of iron 3 hydroxide, I would take 1 iron plus 3 oxygens plus 3 hydrogens, add up their masses from the periodic table, multiply by how many I have, and then that is called the molar mass of iron 3 hydroxide. So if I had ammonium sulfate, I would need to write the formula first before I could go and add up the molar mass on the periodic table. Remember that you can use your periodic table and your polyatomic ions in order to write the formula, which we learned last unit. So ammonium is NH4. It'll have a subscript of 2, and sulfate is SO4. If you don't recall, the reason there's a 2 here is because ammonium is a +1 and sulfate is a -2. We need this subscript to balance the charges. Now we could go to the periodic table and we can add up the molar mass of all of these atoms. Remember the diatomic elements. We start at 7, make a 7. Hydrogen is the 7th element. So here they are highlighted for you. When you have a diatomic element, to find the molar mass, you simply take its mass from the periodic table and then double that number. So hydrogen has a mass of 1.01, and then H2 will just double this number, and that's the molar mass of H2. Cl by itself has a mass of 35.45. Cl2 will have 35.45 times 2, which is 70.90. So molar mass can be expressed with different wording. If we have gram atomic mass, GAM, then that's 1 mole of an element. If we have gram formula mass, that's a mole of an ionic compound. Gram molecular mass is for a molecular compound, and then molecular mass or weight is also for 1 mole of a molecular compound. But we are going to stick with molar mass as often as possible in this course. So find the molar mass for these compounds. For sulfur trioxide, we have to translate that first. Sulfur, 1 sulfur, tri means 3 oxides, so it's going to be SO3. Now we'll look at the periodic table to add up the molar mass. Here is sulfur, and it has a mass of 32.066, and here's oxygen, 15.999. So we'll put 32.066 plus oxygen is 15.999, and then because there's a subscript of 3 next to oxygen, we will multiply by 3. 1 sulfur plus oxygen times 3 equals, and now let's add it up in our calculator. 32.066 plus 15.999 times 3 equals, and we get 80.063. We'll just round this off at the second decimal place, so it'll be 80.06. The unit for molar mass is grams per mole, and this is the molar mass of sulfur trioxide. To find the molar mass of calcium iodide, I'll go to the periodic table and find calcium, which is 40.078, and iodide is 126.904. So it's going to be 40.078 times 1 calcium plus iodine 126.904 times 2, and that's going to be equal to my molar mass. We'll go add it up on the calculator. 40.078 plus 126.904 times 2 equals, and then we'll round this off to the second decimal place, 293.89. The unit for molar mass is grams per mole, and remember this was of calcium iodide. Now let's find the molar masses of all of these examples and then unpause the video to see the answers. First, we need to write the formula for barium hydroxide. Barium and hydroxide. Barium is a +2, hydroxide is a -1, which means I need 1 barium and 2 hydroxides. Now, when I want to add this up on the periodic table, I'm going to need 1 barium plus this 2 distributes into the parentheses only, so I'm going to have oxygen times 2 plus hydrogen times 2, and that's going to equal the molar mass. So we have 137.328 plus 15.999 times 2 plus 1.008 times 2 equals 171.34. And that's grams per mole of barium hydroxide. For calcium phosphate, we're going to take calcium times 3 plus this 2 only distributes into the parentheses, so we're going to say phosphorus times 2 times 1 is 2 plus oxygen times 2 times 4 is 8, so it's oxygen times 8, and that'll give me my molar mass. This will be 40.078 times 3 plus 30.974 times 2 plus 15.999 times 8 equals, and we get 310.17. The unit is grams per mole, and it is of calcium phosphate. F2, we're just going to take fluorine from the periodic table and multiply it times 2 in order to get our molar mass. So 18.998 times 2 equals, we get 37.99. Basically, this rounds up to be 38.00. And that's grams per mole of fluorine gas. Next is copper 2 nitrate. We're going to take copper plus, only distribute the 2 into the parentheses. This is 1 nitrogen times 2 equals nitrogen times 2 plus oxygen, and we have 2 times 3 is 6, so oxygen times 6. We have 63.546 plus 14.007 times 2 plus 15.999 times 6 equals. We get 187.55. The unit is grams per mole of copper 2 nitrate. To add up the molar mass of CH4, we'll take carbon plus hydrogen times 4 equals, so it'll be 12.011 plus 1.008 times 4, In the calculator we get 16.04. The unit is grams per mole, and this is of CH4. Neon gas, which is just neon. It is not a diatomic, so it does not get a 2. So I just go to the periodic table and look up the mass of neon, which is 20.180, and then that's grams per mole of neon.